So the equation says 9 to the power x plus 1 minus 10 times 3 to the power of x plus 1 is equals to 0. So what do we do in this term? So first let's go and write 9 in terms of 3, right? So we know how do we write that? So we can write that in terms of 3 times 3, everything to the power x plus 1 minus 10 times 3 to the power of x plus 1 is equals to 0, right? Now you know 3 times 3, we have the same base, right? So if you remember our exponent rules, what did our exponent rule says? If you have x times x, you have the same base, you simply add the exponents, right? X plus 1 is 2, therefore it will be x to the power of 2. In this case, we'll be using the same thing, right? Because we have our base is the same, right? You can see our base is the same. So we simply say 3 to the power of 2, everything to the power x plus 1 minus 10 times 3 to the power of x plus 1 is equals to 0, right? What do we do? Now we need to simply multiply these two with the x and with the 1, right? So we got 3 to the power 2x plus 2, because 2 times x is 2x and 2 times 1 is 2. Next we write minus 10 times 3 to the power of x plus 1 is equals to 0, right? So what's next now? So now let's go and separate the 2x and the 2. So we can separate that by saying 3 to the power 2x times 3 to the power of 2 minus 10 times 3 to the power of x plus 1 is equals to 0. So now what do we do? Let's remind ourselves that if you have a to the power 2x, this is same as a to the power x, everything outside 2. Because when you have a power inside a bracket and a power outside a bracket, you simply multiply the power. So we have the same in this case. So in this case, we'll just simply come and write 3 to the power x and everything outside times what is 3 to the power of 2. 3 to the power of 2 gives us a 9 minus 10 times 3 to the power of x plus 1 is equals to 0. Now if you look at that, we can see this is in form of a squared plus bx plus c. So what do we do? In this case, we'll use something called a k method, right? So now the next question is, what do we let ourselves to be k? So we let k to be 3 to the power of x, right? We can see there's 3 to the power of x here and 3 to the power of x. So let's go and replace k with 3 to the power of x. So wherever we find 3 to the power of x, we'll just simply write k squared times 9 minus 10k plus 1 is equals to 0, right? Now this looks something that we haven't seen, right? So let's write it in the form that we understand. We know that a times b and b times a is same thing, right? So we'll just simply write 9 before. So we'll have 9k squared minus 10k plus 1 is equals to 0. So from here on, we can simply find the factors, right? So what is 9 times plus 1? That gives us a plus 9. So now we need to look for factors such that when we add or minus, we get negative 10, but when we multiply, we get plus 9, right? So what are those factors? We know those factors are 9 and 1, but what is their sign? They are both negative, right? Because when you say negative 9 times negative 1, so negative times negative gives you a positive, and 9 times 1 gives you a 9, right? And if you have negative 9 plus negative 1, you get the answer as negative 10, right? Because plus times negative gives you a negative 1. So therefore we got negative 1, negative 9. That's a negative 10, right? So our two factors are negative 9 and negative 1. But are those our factors? The answer is no. Why? Because we have a 9 in here. Can you see the a? A is equals to 9. Always remember, if your a is greater than 1, then your factors can never be the one you found. You always have to divide your factors by a. So our two factors are negative 9 over 9 and negative 1 over 9. So 9 over 9, that becomes a negative 1. So let's go and write that. So our new factors are k minus 1 and k minus 1 over 9 equals to 0. But we can't leave this in a form of a fraction. So whatever is your denominator, you simply multiply with k. So new factors are k minus 1 and 9k minus 1 equals to 0. Now it's time to solve for k. So we got k minus 1 equals to 0. But if you remember, we said that let k be equals to 3 to the power of x. Now it's finally time for 3 to the power of x to come and take its position. So now we will have 3 to the power of x is equals to 1, because 1 jumps to the other side. It was negative, so now it becomes positive. You know, from our exponent rule, anything to the power of 0 is equals to 1. So we'll this write in terms of 3. So we'll have 3 to the power of x is equals to 3 to the power of 0. Therefore now if the base are the same, they'll just get rid of each other and x is equals to 0. And the other x we get is 9k minus 1 is equals to 0. So how do we solve this? We know, first let's go and solve by taking the 1 the other side, and let's remain with k on one side. So now if you have 9k equals to 1, you simply divide by 9 here, right? So if you divide by 9, you get your answer as k is equals to 1 over 9. So the new one is now k equals to 1 over 9. What do? Again, we need to replace k with 3 to the power of x, because that's the original one, right? 1 over 9. Now, from the exponent rules, you know, a to the power minus 1 is same as 1 over a, right? So this is in form of 1 over 9. So we'll simply take 1 over 9 and write it as 9 to the power minus 1, correct? But now here we have a 3 and here we have a 9. So how to write 9 in terms of a 3? So 3 squared is same as 9, right? Because 3 times 3 gives you a 9. So here we'll have 3 to the power of x is equals to 3 to the power of 2, everything to the power of minus 1, right? So here we'll simply multiply minus 1 and minus 2. So 3 to the power minus 2. So what does our exponent rule says? It says that if you have a to the power of 2 and outside you have a 2, you simply multiply the exponent, right? 2 times 2. That's what we did here. We simply said 2 times minus 1, and now we can see we have 3 and 3, same base, so we get rid of the base and we write our x is equals to minus 2. So our true answer is x is equals to 0 or x is equals to minus 2.